Hey, Mr. Odom. Hey, Mr. Odom. That's a good one. Hey, everybody. Mr. Odom here. And that was good. It's the end of the school day, so I'm a little tired. I am going to cover section 2.3 and talk about how do we subtract rational numbers. It's going to be pretty straightforward because we're going to use the same rules we did for the last chapter when we subtracted integers. And all we have to worry about are the fraction pieces. Do I have to have a common denominator or not? And that's pretty much it. So the learning targets for this video are I can subtract rational numbers, and then you can find the distance between numbers. So hopefully you'll be able to say those things. Don't forget your pencil, your composition book, and your notebook paper, and your calculator. So let's get started. I kind of got started a little while ago and wrote some stuff down. So to subtract rational numbers, you use the same rules for signs as you use for integers. So remember what we did for integers, we would add the opposite, which I wrote over here. Add the opposite. Okay, and that's fine. You can do that. You just have to make sure that your denominators are common. If you have common denominators, you go ahead, turn your subtraction problem into an addition problem, and go ahead and combine those rational numbers. For decimals, it's pretty easy. You're just going to pick up your calculator, and you'll go ahead and punch those numbers in and make sure you check your answer to make sure it makes sense. So I did problem number 1 over here. I'm going to do problems 1 and 2, and I'll leave the rest for you to practice. But for the first one, what did I do? I wrote the problem down, and then I just added the opposite. So I wrote, when I'm adding the opposite, I write the first fraction down, a rational number. I change the sign, and then I write down the opposite of the second rational number. So I did that right there. These two rational numbers have a common denominator. So I go ahead and just add the numerators together. 1 plus 1 is 2, and I get 2/3, and I'm happy because I got it right. All right, let's look at number 2. So this problem, -3 1/3 minus 5/6. So what I'm going to do first is change the mixed number into an improper fraction. I'm going to do that part first. So what did I do? Multiply 3 times 3, 3 times 3, and then I add the 1, and I put that in the numerator, put it all over 3. The next thing I'm going to do is find a common denominator, which would be 6. So this first rational number becomes -20 over 6 minus 5 over 6. Okay, and I can go ahead now and I can combine those numerators. And remember, if there's a negative sign, it's going to go with the number in the numerator. So this becomes -20 minus 5 all over 6. All right, and now I can change my numerator where I have these two integers. Think in the numerator, I have two integers, -20 minus 5. Turn that into an addition problem. So this will be -20. I'm adding, so I need to add the opposite of +5 is -5. And then all of that is over 6. Okay. And then from here, I can sing the song, same sign, add and keep, different sign, subtract, keep the sign of the bigger number, then you'll be exact. So these have the same sign. So in my numerator, this will be negative. And then I add those absolute values. Absolute value of -20 is 20. Absolute value of -5 is 5. I add those together. I get 25, and I keep the sign, so it'll -20 plus -5 is -25. All of that over 6. Okay, and then if I'm going to write this answer down, I can write it like this: negative, put it in front of the rational number, -25/6. And for this problem, for these problems, I think we had to write, let me look at the directions. I didn't write them down up here. So we had to subtract these, but we also sometimes have to write our answers as mixed numbers. This is a perfectly good answer. But sometimes in big ideas, they want you to write your answer as a mixed number. So then how do I do that? Well, how many times does 6 go into 25? Well, it goes in 4 times. 6 times 4 is 24. So there's one left, and it's over 6. And don't forget to bring along that sign. So we're good to go there. All right. Let's look at, actually, I'll go ahead and let me go back up here and pause the video. And I want you guys to work out, let's see, I worked out problems 1 and 2. I want you to work out problems 3, 4, 5, and 6, and then come back. All right, so we're back. What'd you get for number 3? Hopefully you got an answer of negative 3/4. And then for number 4, you should get an answer of negative 15.1. For number 5, the answer should be 0. And then for number 6, the answer should be 0.48, or 0 and 48 hundredths. Right, so hopefully you got those right. Yay, you got them all right, hopefully. Fingers are crossed. All right, and if you didn't, then tomorrow, ask me, hey, Mr. Odom, can you work out these problems? I was a little confused. Can you help me? Can you help me? And I will say, yes, I can. Yes, I can. All right, so let me move on. So find the distance between negative 7.5 and negative 15.3 on the number line. So I'm going to put negative 15.3 right there. On my number line, I'm going to put negative 7.5 on my number line right here. And let's say 0 is somewhere over here. Okay, so we know these two numbers are negative. And when I go this direction, numbers get smaller. Okay, so how do I solve that problem? Well, a good strategy that I like to use is to solve a simpler problem. Okay, solve a simpler problem. So let me make a simpler problem and we'll figure that out. So I'll say 1 is here and that'd be 2. And let's say 3 is here. And I want to know what's the distance between 1 and 3 on the number line. Well, I can see that it is 1, 2 units. So I can count that. That's pretty easy, 2 units. But is there a way I can look at this mathematically so that I can get an answer of 2? And there is. I can set up a subtraction problem. Remember, that's what this section's about, subtraction. So 3 minus 1 is 2, and that tells me the distance, okay, between these two numbers on a number line. So here is the process that I need to use for this problem. Okay, so let's go back and let's look at this one. What am I going to do? Well, when I worked out my simpler problem, I took the larger number and I subtracted the smaller number. Let's see how I did that. So I'm going to do that again. On this number line, remember, numbers to the right are larger than numbers to the left. So that means I need to take negative 7.5 and I need to subtract negative 15.3. All right, let me add the opposite. So this will be negative 7.5 plus 15.3. And then you can go ahead, jump on your calculator, see negative 7.5 plus 15.3. What do I get? What do I get? I get a positive answer because remember, distance is positive, 7.8. All right, so that's how you solve distance problems. Just take the larger number on the number line, subtract the smaller one, and that will give you the distance. So that's all I have today. Hopefully this was helpful and a good reminder for you on how to subtract rational numbers. It's been awesome working with you. This is Mr. Odom, and it's time for me to go. Bye.